Now let us explore the computer network's topologies. What is a computer network topology? What is meant by the word topology? The word topology means the arrangement, the structure of the various elements of a computer network, which depicts both physically and logically. The physical topology is the physical way the network is wired, how the computers are connected to each other. The logical topology identifies the way messages are sent, how to send a message, and how a message moves from one machine to another. The topology can be explained in a physical and logical essences. The basic network topologies, the most common, the most well-known topologies are the point-to-point topology, the bus topology, the ring topology, the star topology, and the mesh topology. Now we will explore one by one of them. The point-to-point topology is just a link, a physical link, either a cable or a wireless link that is connecting two points. Or it can be a logical link, logical point-to-point connection, that is passing through an ISP, Internet Service Provider, connecting a source node to a destination node. It's a dedicated link, a dedicated media to connect these two nodes only. The bus topology is a single cable that functions as a bus, as a shared media, as a backbone. Computers attach or tap with an interface connector to this bus. This bus, this shared media, is terminated by terminators, and the computers are connected through connectors either in T-piece or in Y-piece. We can see here the topology of the connection and the connectors, the T-piece, the Y-piece, and the terminator that resides at the end of the bus cable. The advantages of the bus topology is that it is simple to design, very simple to design and very easy to install. It is also inexpensive due to using the coaxial cables as the shared media and using the B and C connectors, BOINET, nil, concealment connectors. These type of connectors are very cheap, inexpensive, and very efficient in working. The disadvantages of this bus topology is the security. This topology allows for sniffing. Every message passing from one machine to another can be sniffed by any other machine on the same bus. This means that the privacy of the message, the confidentiality of the message can be tackled anytime it's passing the media. The bus topology is slow during high traffic. If high traffic is introduced to this topology, the speed of the whole network goes down, leading to poor performance. The bus topology allows for collisions. Collisions means that assume that two machines are sending their messages at the same second. Both of messages will exist on the shared media at the same second as well. So both messages will collide with each other. Here is how collision happens. Zeros and ones of both messages will no longer be zeros and ones. They will be something else that is called jam signal. Something that has no meaning, that is meaningless, which means that we have to retransmit both messages again, which means poor performance and slower network and many times of retransmission. The third topology is the ring topology. The ring topology basically is a cable in the form of a ring as shown that connects one node to another to form a ring. The ends are attached to each other in the form of a ring. Messages travel through this ring always in the same direction, always in one direction, either clockwise or anti-clockwise. The messages are transmitted in frames that circulates all the machines, which allows for sniffing, obviously. The ring topology allows for acknowledgement. The sent frames circulates back to the source of the message to acknowledge that transmission has been done and to set the frame free for another machine to put its message on the same frame to be sent as well. The advantages of the ring topology is that it is simple also to design, easy to install. It's very inexpensive due to using the coaxial cables and the BNC connectors. It looks like the bus topology in this side. The disadvantages of the ring topology is that the entire network fails if only one machine fails, because it breaks the ring. It stops the messages from circulation. So the whole network fails if only one machine member of this network fails to connect. The expansion of this network or reconfiguration affects operation. Imagine that you want to expand this network. You have to stop one of the machines, add another machine. You will have to break the ring, and the circulation of messages will stop for some time until you finish the expansion or reconfiguration. Then the operation is restored. The ring topology is also slow for big numbers of machines. If a big number of machines is installed in ring topology, this leads to slow network and poor performance also. The star topology. This is the most well-known, the most common topology that is used nowadays in networks. The star topology depends on connecting each station directly to a central device as seen in the image. The connection is like a number of point-to-point links. Each machine looks like being connected in a point-to-point link to this central device. This central device can be a hub or a switch. Nowadays, switches are more commonly used than hubs. The switch is a more recent technology and more secure device. The switch allows for no sniffing to be done, while the hub allows for sniffing to be done on the network. The switch allows for no collision to take place, while the hub allows for collisions to take place. So, the switch is now the most used technologies in connecting a number of machines to each other in a local area network or a LAN. The advantages of the star topology is that the network is not affected if one machine fails or if the network is reconfigured. The network expansion is very simple. You just add the new machine to the switch or the hub without affecting the performance or the operation of the whole network. Troubleshooting is easy. You can easily identify the failing machine from the switch. You can easily identify where the problem or where the broken cable exists. The disadvantages of the star topology is that if the central device fails, all the network fails. And this is very rare to happen. This is not common to happen. Central devices are so far reliable. The mesh topology means that every device is connected to the other devices through a separate link. It connects all devices with multiple paths. So, between each device and another, you can find multiple paths that can connect such device to the other one. It offers a very high redundancy in connection, which means very high reliability, which is part of the security of the network. The number of cables equals to the number of connected nodes multiplied by the same number minus 1 and then divided by 2. This equation is used to calculate the number of cables used in any mesh topology, knowing the number of connected nodes. The advantages of the mesh topology is that it is very high fault tolerant. It allows for broken cables to exist because any broken cable can be substituted with another path for a good cable to exist. It's very secure since it has high availability, and availability is part of the security. So it is very secure from this point of view. The disadvantages of the mesh topology is that it is expensive due to using big number of cables, and due to offering high redundancy, this leads to very high cost sometimes. By this, we come to the end of the computer networks topologies, and we hope that we clarified the most known and common basic computer network topologies. Thank you.